Good morning. I hope you're all doing well and we are continuing with our classes on electricity. Lot of problems in electricity because it is a chapter from where problems will come. So the next problem based on resistances in series and parallel. A wire of resistance R, I don't know, problem number 20. Okay. Wire of resistance R is cut into 3 equal parts. Is cut into 3 equal parts. If the 3 equal parts, or if these parts are connected in parallel, if these parts are connected in parallel, calculate equivalent resistance, calculate equivalent resistance of the combination, calculate equivalent resistance of the combination. Okay, this is something similar to what we did yesterday. So we have a wire which has a resistance R. It is divided into 3 equal parts. What will be the individual resistance? R by 3, R by 3 and R by 3. These R by 3 parts are then connected in what? Parallel. In parallel, we have 1 by Rb is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So, it is 1 by R by 3 plus 1 by R by 3 plus 1 by R by 3, which will become equal to what? 3 by R plus 3 by R plus 3 by R, which is equal to how much? 9 by R. 9 by R is equal to 1 by Rp. So Rp is equal to what? R by 9. This is how our answer will be. Rp is equal to R by 9. What should be the unit there? Rp is equal to R by 9 ohms. Okay, now for the 17th one, 21st one, the next problem. Okay, please write for the circuit shown in the following figure, 21st problem, for the circuit shown in the following figure, calculate A, total resistance, B, total current, and C, voltage across 7 ohm resistor. Voltage across 7 ohm resistor. So let us first draw a circuit diagram. This of 5 ohm and 10 ohm. This is how is our circuit. Now we need to calculate the total resistance. So we know these two are connected in what? Parallel. This is connected in series. So first 1 by Rp is equal to 1 by 5 plus 1 by 10. Let us understand LCM to be 10. 2 plus 1. So it becomes what? 3 by 10. So Rp is equal to 10 by 3, which is equal to 3.5. 3.5. 3 3s are 9. 3 3s are 9. 10 minus 9. 1. 3.3 ohms. Okay. Now total resistance. Is equal to 7 plus 3.3 ohms. 7 plus 3.3 ohms is how many ohms? 10.3. 10.3. So it becomes 10.3 ohms. Or you can write this as 3.33. So this becomes 10.33 ohms. Okay. Now I have to find out what? Total current through the circuit. So total current, how do I find out? Which formula do I use? V is equal to IR. V is given as how many volts? 6 volts. I have to find out. R, I can take it as 10 by 3, sorry, 10.33. So 6 by 10.33 is equal to I. So you divide 6 by 10.33, you will get your answer as somewhere around 0.58. 0.58 ampere. If you can't solve this 10.33, you can also do it like I take this as what? 10 by 3. So I can take 7 plus 10 by 3 and take the LCM and do. Still I will get the same answer. You will get what? 0.58 ampere. The second part over. Now for the third part. Voltage across 7 ohm resistor. See, again I will use the formula V is equal to IR. I need to find out V. What is I? 0.58 and what is R? 7. Multiply, you will get the voltage. 0.58 into 7. Okay, 0.58 into 7, it will come as 4 point something. 4.06, 4.06 amperes. So this is how we will calculate the current. Done. Now we will come back to our textbook questions or the in-text questions which are given for resistances in series and parallel. Okay. Judge the equivalent resistance when the following are, can come to page number 216. Come to page number 216. The first one, judge the equivalent resistance when the following are connected in parallel. 1 ohm, 10 to the power of 6 ohms. B, 1 ohm, 10 to the power of 3 ohms and 10 to the power of 6 ohms. Okay, so you will do the same thing again. It's very simple, but only thing is there are parts, so you need to do it or make it into zeros and do it how you feel comfortable. I have taught you so many problems, and these problems you should be able to do around, say, it says you have two resistors of 1 ohm and 10 to the power of 6 ohm connected in parallel. So let us first draw. We have these 2 ohms, 2 resistors, 1 ohm connected in parallel to 10 to the power of 6 ohms. I always told you whenever diagrams like this come, you are supposed to draw, problems like this come, you are supposed to draw the diagram. So this is it. Now 1 by Rp is equal to 1 by 1 plus 1 by 10 to the power of 6 ohms. Correct? We will take LCM as what? 10 to the power of 6. So 10 to the power of 6 plus 1 is equal to 1 by Rp. So Rp is equal to 10 to the power of 6 by 10 to the power of 6 plus 1. How do you solve this? I will pause, just try solving it. Okay? And if you don't get it, I will teach. Yeah, so very simple. I made this 10 to the power of 6 written like this. 10 to the power of 6 plus 1. So here, because we will not have much difference between the denominator and the numerator, there is only a difference of 1. So we approximate it to be how much ohms? 1 ohm. Now the B part of the question. The B part of the question says we have 1 ohm, 10 to the power of 3 ohms and 10 to the power of 6 ohms connected in parallel. So now my diagram will change. Now my diagram will change and it will have one more resistors which will have how much ohm? 10 to the power of 3 ohms. So now my Rp becomes 1 by Rp is equal to 1 by 1 by 10 to the power 6 by 1 by 10 to the power 3. Okay? What should be my LCM now? 10 to the power of 6. So this becomes 10 to the power of 6 plus 1. 10 to the power of 3 and 10 to the power of 6, 2. So can you solve this? Can you solve this? Please solve it and finally get your answer. It will be somewhere around, I won't tell, but let us try. Just pause it and try it. Yeah, so while solving the problem, where you go wrong is when you take your LCMs like this and you get 10 to the power of 3, you write it as 2, which is wrong. Always make this in the form of zeros so that it is easier for you to understand. So this is our 10 to the power of 6. If you take the LCM, you will get it as 10 to the power of 6. Second one, 10 to the power of 6 into 10 to the power of 6, 1. Now 10 to the power of 3, it is not 2. It is what? 10 to the power of 2. 10 to the power of 2 is what? 100. So now you will add and you will get this number as 1 by Rp. So Rp, if you divide, you will get is what? 0.99 ohms. Very important question. Always understand if it is given in bars, simplify it by adding zeros rather than showing that you know how great you are in mathematics. Okay. Now coming to the second problem. An electric lamp of 100 ohm, a toaster of 50 ohms and a water filter of resistance 500 ohms are connected in parallel to a 220 volt source. What is the resistance of an electric iron connected to the same source that takes as much current as all the three appliances, and what is the current through it? So first thing, what are the three resistors which are connected in parallel? Let us first write. So we have three things connected in parallel. First one being what? 100 ohms, 50 ohms, and the next one is what? 500 ohms. These are connected in parallel to a 220 volt source. So B is given as what? 220 volt. What is our total Rp? 1 by 100 plus 1 by 50 plus 1 by 500. Okay, what will be our LCM? 500. So 100 5s are 50. How many is 500? 10s are and 500 1s are. So 10 plus 1 11, 11 plus 5 16. So you get 1 by Rp is equal to 16 by 500. So Rp is equal to what? 500 by 16 ohms. Divide that 500 by 16. 31.25. Correct. So you get Rp as 31.25 ohms. This is what is the resistance of an electric iron connected to the same source that takes as much current as all three appliances, and what is the current through it. So we need to find out what current. We will use the formula V is equal to IR. V is 220 volt. I need to find out. R I'm taking it as what? 500 by 16. Divide ಮಾಡ್ತಾ ಇಲ್ಲ. ಹಂಗೆ ತಗೊಳ್ತಾ ಇದ್ದೀನಿ. So you get 220 into 16 by 500 as I. So cancel this. 2 ones are 2 are 25. That much only, no? Something else can be divided? I don't think so. Multiply 16 into 11 by 25. You will get your answer as I. Or if you don't want to do this circus, directly take 220 by 31.25. Your answer will be how much? 7 huh? I don't know. Just check your answer. It will be somewhere around 6.5 or 6.4. Divide and check your answer. It should come approximately, I don't know, 6.4 may be wrong also. 16 into 11 is to 176. 176 by 25. Divide and check. I think it should be somewhere around 7. 25 sevens are 175. So 7 point something it will come. 7 point, just check. 7.4, 7.5. I don't know, that part you check. Next. 7.04. 7.04. Okay. So 7.04 amperes is your answer. Now coming to the next one. What are the advantages of connecting electrical devices in parallel with the battery instead of connecting them in series? Taught? Yes or no? Yes. How can mark this fourth problem? Very important. How can three resistors of resistances 2 ohms, 3 ohms and 6 ohm be connected to give a total resistance of 4 ohms at 1 ohm? ಈಗ 1 ohm ಅರ್ಥ ಆಗುತ್ತಲ್ಲ ನೋಡಿದ್ರೆ, see 2, 3 and 6 ohms. The resistance should be 1 ohm. It is smaller than the smallest resistance. So it can be connected in parallel. So first thing we will try the first part of it or the second part of it. We will try first 2 ohms. We have 2 ohms, 3 ohms and 6 ohms. I am just trying, okay? I do not know. But what is the concept I am using? That in a parallel circuit, the total resistance is always smaller than the smallest resistance. So 1 by Rp is equal to 1 by 2 plus 1 by 3 plus 1 by 6. LCM 6, 2 3s are, 3 2s are, 6 1s are. So 1 by Rp, 3, 4, 5, 5 and 1, 6. So Rp is equal to 6 by 6, which is equal to how much ohms? 1 ohm. Second part clear? Now the first part. You should get how much resistance? As 4 ohms. Iga logic artha ಮಾಡ್ಕೊಳ್ಳಿ. 2, 3 and 6 connected in series will become how much? More than 6 ohms. But I have got what? 4 ohms. I have 3 resistors. One can be in series and the other 2 can be in parallel. So see, 1 by 3 plus 1 by 6. If I do rough work multiply, 1 by 3 plus 1 by 6 multiply 6. 3 2s are 6. 1. So you get 3 by 6, which is 6 by 3. It is 2. And that 2 and that 2 can be connected in series. So it becomes what ohms? 4 ohms. So like this, by trial and error method, you will have to find out. So the second part of diagram, it will be like this. This is my 2 ohm resistor, and then it is connected in parallel to 3 ohms and to 6 ohms. This is 3 ohms, this is 6 ohms, and this is 2 ohms. So first 1 by Rp is equal to 1 by 3 plus 1 by 6. LCM 2, 1. 3 by 6 is equal to 1 by Rp. So Rp is equal to 6 by 3. It is how much ohms? 2 ohms. Total resistance. Plus 2, which is equal to how much ohms? 4 ohms. Understood how to do it? Diagram is a must. Without diagram, nobody will give you marks. Now, the next question. What is the highest and the lowest total resistance that can be secured by the combination of 4 coils of resistance? 4 ohm, 8 ohm, 12 ohm and 24 ohms. For highest we will connect in series, for lowest we will connect in parallel. So right. Next question. This is the last question of the in-text part. The fifth one, we write for highest resistance connect in series. So 4 resistors are connected in series. What are our 4 resistors? 4 ohm, 8 ohm, 12 ohm and 24 ohms. So Rs is equal to 4 plus 8, 24. 8 plus 4, 12, no? 12 plus 12, 24. 24 plus 24, 48. Answer is what? 48 ohms. This is to get what resistance? Highest resistance. Now, to get lowest resistance. To get lowest resistance, connect in parallel. Connect in parallel. So this is how we will connect. 1, 2, 3, and we have the fourth one. This is how you get a wire jointed in places. So you have how many ohms? 4 ohm, 8 ohm, 12 ohm and 24 ohm. What should be my answer? My answer should be less than 4 ohms. So 1 by Rp is equal to 1 by 4 plus 1 by 8 plus 1 by 12 plus 1 by 24. LCM 24. 4, 6 are 8, 12, 2s are 24, 1s are. So 1 by Rp is equal to 6 plus 3, 12. Total 12, 12 by 24. So Rp is equal to 24 by 12. So which is equal to how much ohms? 2 ohms. So this is all what we have done in resistances in series and parallel. Now from tomorrow we we will start doing heating effect of electric current. I will finish all together heating effect of electric current, practical applications and electric power, and then go for problems of each. I hope you have done at least 20 to 25 problems till now from the beginning. Every time there is a test, you have to go through all these problems, and if you find that you are not able to understand it, please message, because electricity is a big chapter and I won't be able to repeat multiple times the same thing. Thank you.